I just want to do a quick introduction. I did the opening yesterday. I'm really proud to introduce Dr. Jim Zimbelman. He is a geologist. You might not know this, but the Smithsonian is an institution dedicated to the increase and diffusion of knowledge. And many folks don't realize that behind the scenes at the museums across the mall are research divisions doing really remarkable things. One of the research divisions here at the National Air and Space Museum is the Center for Earth and Planetary Studies, and one of the folks on staff is Dr. Jim Zimbelman, who is a geologist in SSEPs, and he was gracious enough to come in this morning and talk about some really remarkable things in the museum. So let me just turn this over to Dr. Jim Zimbelman, and it's been a pleasure working with you over the years, so here you go.
Thank you, Jeff. And one of the things I would like to emphasize that you students in particular should keep in mind is the friendships you will make here and then as you continue on in school. Jeff was an astronomer, I'm a geologist. You wouldn't think we'd have a lot in common, but I remember a lot of very lively discussions with him and others. That's part of the fun of science, and you have an opportunity to make some very important friends, perhaps for a lifetime, just through these activities. And I'll also say, I wish I could have done what you guys have done. I mean, I can't imagine as a kid in middle school or high school being able to fly an experiment in space. How cool is that? Well, what Jeff and I talked about and what I want to briefly tell you about are some of our robotic explorers of space. Now, when I say robot, you think of, you know, an android kind of thing. Well, a robot really is any mechanical device that is doing something in our place. Early in space flight, we couldn't send people to the places that we wanted to investigate, so we used robots. And some of the real important ones are here in this gallery and in a couple other places in the museum. So I'll just quickly walk you through that. You guys have probably read some of the labels and stuff already, but I'll just point out some of the more important ones. Now, space flight exploration is dependent on rockets, and we're used to that, but be aware that over here is one of Robert Goddard's later models of a rocket. And down below it is a model of his very first one. This little thing down here was the very first liquid-fueled rocket in the world, 1926. He was still figuring out how to do that. By 1941, this larger one has all these pipes and fittings, the fuel tanks up here. It was carrying very simple devices because they were still trying to figure out how to make rockets work. Well, that's kind of the grandfather of all of our space venturing vehicles. They are carried on liquid fuel rockets, much like Goddard built here. Now, the very first exploration of space, the beginning of the space age, is represented by what's up above you. This silver ball here is a full-size model given to us by the Russians of Sputnik. Now, you've probably at least heard of that name, I think, but perhaps you don't realize how that word put the incredible fear, particularly in the United States. Why was that? Well, here was a device launched by the Russians, at this point our adversaries, that flew around the Earth and in particular flew over the United States. And I still remember my father telling me how scary that was, that they'd look up in the night sky and see this thing and could turn their radios to this frequency that the Russians had told them about and hear it beeping. Now, it was not making measurements, but it was an incredibly important propaganda experience by the Russians. We were in what was called the space race at that point. And what was that? Simply to get more things, bigger things into space before your adversary, the Russians in this case. Well, the Russians beat us in October of 1957 with Sputnik. That stimulated sort of a crash program. The US had been trying things that weren't working terribly well, but Explorer, this pencil-like device, went up in January 1958, only a few weeks after Sputnik. Very different designs. I want you to keep that in mind too. The programs of Russia and the United States, interestingly, were both outgrowths of German scientists who, after World War II, some had been captured by the Russians, went to Russia, some were captured by the Americans and came to the U.S. Very different philosophies of how they designed things. The short answer is the Russians were big and sturdy, and they had big rockets. They could launch whatever they wanted. The U.S. tended to be smaller and often more streamlined, or at least sophisticated looking. It was just the different philosophies the two camps used. Now, one of the important differences, between Sputnik and Explorer, Sputnik operated for 22 days, scared the non-communist world to death. Its primary function was to demonstrate that they could do that, and it had a radio transmitter. That was its only operational device. Explorer, on the other hand, these little wires sticking out of the side of it here, these are antennas that sent information back to the Earth. That was an actual scientific measurement. Explorer was the first spacecraft to demonstrate that outside of Earth's atmosphere were radiation belts. Now, again, you guys are used to hearing about that. That was brand new in 1958. It had been predicted by certain scientists, but we had never observed them before. Well, James Van Allen was one of the scientists responsible for getting that simple experiment on Explorer, and we now call these things the Van Allen radiation belts after him. 1958 was when that first happened. That operated for over 100 days, so a bit longer scientific operation. So late 1950s, the beginning of the space age. And in a sense, Explorer was the first robotic thing because it returned some useful information about Earth. What I want to emphasize real briefly here are the things that went beyond Earth. And it didn't take terribly long. This spacecraft up here, it's maybe a little hard to see where I'm pointing, but this is a full-size engineering mock-up of something called Mariner 2. Mariner was a series of exploration spacecraft, robots, launched by rockets to explore things beyond the Earth. And Mariner 2 has the distinction of being the first planetary vehicle to return useful data from another planet, in this case Venus. Mariner was launched, took 109 days to fly to Venus. It didn't go into orbit, just flew by it, but in that flyby process made radio measurements of the planet that demonstrated something terribly important. They measured radiation coming off of the planet that indicated the temperature on Venus was a lot hotter than anybody had been thinking up to that point. Estimate was 30 degrees Celsius. That's about 800 degrees Fahrenheit. That blasted all kinds of science fiction writers' ideas of what Venus had been. We knew it was cloud covered. Jeff's studied Venus quite a bit through telescopic work. Those clouds made it very hard to understand what was there. Well, Mariner 2 was the first time we got a real measurement from the vicinity of the planet sent back to us here at Earth, 1962. Next, let's look at this spacecraft up here. This is another full-size engineering mock-up of Pioneer, in this case Pioneer 10. Now there are all of these different names, Mariner, Pioneer, Explorer. They are a series of spacecraft, and we're just showing you some of the more important examples for one reason or another. Well, Pioneer 10 is important because this was the first spacecraft to go through the asteroid belt and explore, in this case, Jupiter, the largest planet in the solar system. You might notice these panels that are sticking off of Mariner 10 were solar cells. That's how the spacecraft in the inner solar system were powered, by sunlight. Well, Pioneer was going so far from the sun that these white things on either end of these booms contained small components of plutonium. Now, ours don't. Obviously, they don't have radiation in them, but the decay of the plutonium caused heat, and that heat was translated into electricity. So these were nuclear-powered spacecraft, as a way of thinking about it. That is the only way we can explore the outer solar system, is using these things that don't depend on sunlight to power the spacecraft. Well, Pioneer, again, flew by the planet, was going so fast it couldn't go into orbit. 1973, the first spacecraft to traverse the asteroid belt and get to a planet and make important measurements. Now, how many of you are familiar with the Star Wars movies? Han Solo flying through the asteroids, dodging them? Isn't it all like that? Pioneer demonstrated that it was actually pretty safe to fly through the asteroid belt. We really didn't know. never came anywhere near a large asteroid, large being anything bigger than your fist. What it did measure was dust. On the backs of the panel, all of these little plates here are dust detectors. And there was, in fact, an increase in dust in the asteroid belt, but not that much different than what had been predicted by ideas up to this point. It was just this was the first measurement, and the clear demonstration that the asteroid belt is not an obstacle to exploring the outer planets. We can fly through that quite easily, quite safely, and we've had several spacecraft do that now. Well, next is this spacecraft over here. This is a full-size engineering model of the Viking landers. Viking went to Mars, and the importance of this one is the Vikings were the first successful soft landings on another planet. Mars has received a lot of attention, and many of our scientists in my department here do our work on Mars. We've had many, many successful robotic spacecraft to it. We've had many unsuccessful ones, and the Russians too. Mars has just been a very difficult planet to get to for some reason. Well, in the 1976 era, the Vikings were spectacularly successful. 2 Viking landers landed in 1976. 2 Viking orbiters operated for 4 and 6 years, respectively. Completely changed our ideas about Mars. Now, Viking landers were important historically because they were the first successful soft landings, but also they were designed to look for life. It's just they were designed, they had 3 very elegant experiments that the arm would scoop up some of the Martian soil, deposit some of it inside the spacecraft itself, and do the analysis. They were designed to look for terrestrial life. They didn't find it, and that was actually an interesting sort of change in mindset. Of course, you would design your experiments to look for life as we are used to, but what if life on other planets isn't like us? We demonstrated with Viking that there was not evidence of plant or single-celled animal life extant right now on Mars based on the biology that we're used to here on Earth. Doesn't mean that plants and little bugs haven't figured out another way to do life operations somewhere else. Maybe one of you guys will be involved in better understanding that. The last thing to mention here in milestones is, in this case over against this wall, it's behind this little pillar. A lot of people might tend to miss this because it's over against the wall, but it's actually very important. It is the first time we have returned a sample from an object outside of the Earth system, beyond the moon. Now, the Apollo astronauts brought back moon rocks, and you can touch one right behind us here. Don't forget that opportunity here in milestones, but that was people bringing back the samples. We also have robotic device, and in this case, the Stardust spacecraft flew through the tail of an active comet. Have any of you seen a comet in the night sky or in the morning sky? You know, a couple of you at least. It is well worth seeing. It's mind-boggling to see this thing glowing in the sky and realize that it's tens to hundreds of millions of mile-long tail coming from fairly small objects. Well, we are learning an immense amount about comets. Stardust was very important in that because it flew through the tail of the comet. There's a kind of a, looks like an antenna, but it's more like a catcher's mitt that was extended out of the spacecraft, captured very small particles. How do you capture something going tens of thousands of miles an hour? They have something called Aerogel, and in the case, I'd encourage you to look at this little block of blue stuff that almost looks like it isn't there. Well, that's a good description. 99% of it is empty space. It's open void. But that other 1% is glass threads that can slow these dust particles down without damaging them too severely. So Stardust collected hundreds of individual grains that were in the tail of the comet, brought that device back inside of its shell, and then in 2006 landed in the Utah desert, and we recovered it. That was the first time we had brought back samples from beyond the Earth-Moon system by a robotic vehicle. Now, what we're going to do in the next couple of minutes is go up to exploring the planets, and that is another location where there are several important spacecraft. I'll give you an assignment. What we're going to do up there is just let you wander around. I'm going to be in the far corner of the gallery in the Mars section. Be glad to answer questions for you, but I want you to be able to explore there. It's just I want you to look for 5 things in particular. One is a camera that's about like this size from the Surveyor 3 spacecraft that the Apollo astronauts brought back, Apollo 12. Apollo 11 got all of the attention because it was the first landing. Apollo 12 demonstrated that we could put our people exactly where we wanted them to be. They landed within walking distance of the Surveyor unmanned spacecraft, brought that camera back. Wonderful stories associated with what we learned from that device. Right next to that camera is a big ball, a globe of Mars. And that was made by the scientists at the Jet Propulsion Laboratory in 1971 when Mariner 9 had gone into orbit around Mars. Literally, as the pictures were coming back from the spacecraft, engineers would glue them onto the globe. So this was pre-digital. We had to deal with hard copy kinds of things. That was how we were learning what Mars looked like, literally pasting these things onto this globe as the spacecraft would return another swath of images, and they were sort of building up this picture of the planet. That's still one of my favorite objects in the gallery. 2 spacecraft to be aware of. One is Voyager. It's up above you, and Voyager has really revolutionized our idea of the outer solar system. Pioneer 10 was the first spacecraft to get through the asteroid belt, but Voyagers 1 and 2 explored several of the planets out there in much more detail than the Pioneers could. Our engineering version of Voyager is the only one that I'm aware of in the world that has the magnetometer boom fully extended. It covers almost half of the gallery ceiling area in its length. Most places don't have that room to be able to display that. We're the only one where you can see how far away from the spacecraft itself that magnetometer head was displayed. Another thing to be aware of in the back corner will be a full-size Mars Exploration Rover vehicle. This is a model made by students at Cornell University. The chief scientist, Steve Squires, is a professor at Cornell, and he asked one of the engineering classes to make a model. Now, Steve had access to all of the blueprints, so he gave them the design drawings of the rover. That's as close as you're going to get to a full-size representation of what the rovers look like. But it was made by college students as a project. I think that's a fantastic thing for them to do. And Steve, fortunately, is a very strong supporter of the museum. He has given the model to us in a long-term loan right now. And one other thing to look for in the Mars section is a Mars meteorite. Did you know that we have samples of Mars here on the Earth? Not because a robotic spacecraft brought it back, but they came down for free. They landed as meteorites. But the reason we know that they are from Mars goes back to the Viking landers, which measured the Martian atmosphere in very great detail. Those Martian meteorites trap some of that atmosphere inside them, and when it can be released in a laboratory, it's not like the atmosphere here on Earth or Venus or any other atmosphere that we're aware of, but it is exactly like the atmosphere of Mars. That's why we are convinced those rocks came from Mars. And we'll spend about 20 minutes or so in exploring the planets. When we come back down, I'd encourage you to also go to the far end where the lunar lander model is. Look up. Up above the lunar lander are 4 robotic spacecraft that were terribly important in the exploration of the moon. Ranger, Surveyor, the lunar orbiters, and one called Clementine. And those all were terribly important for increasing our understanding of the moon following the mission of the Apollo astronauts. What we're going to do next is go up the escalator, and I'm going to lead the way, and I asked Jeff to sort of bring up the rear end. We need to only go into the one gallery. That's all we've been approved to do for right now, but we'll spend about 20 minutes in there. I'll be in the back end in the Mars section. Come and ask me questions if you want.